Welcome. Let's look at graphing these reciprocal, or what we would normally call rational functions. That means that the variable or one of the variables is in the denominator. In our textbook, page 415 shows the parent function's main characteristics. Here are actually the main three things I would focus on. There's x values in the denominator. There is an asymptote, which it cannot connect or it cannot go over the graphing. And then the domain and range are not continuous because they stop. For instance, here's the basic graph, basic parent function graph of this is like so. And so when you have an x in the denominator like this, it's going to graph like this because this is an asymptote here. X equals 0, because if you had a 0 in the denominator, you can't do that. You'd be dividing by 0. So that means the graph's not allowed to touch it. Here's an example, for instance, in the Desmos online program, where this is 1 over x here, the red line. And what that does is you can see it could go up further, and it gets closer and closer and closer to 0, but it never actually touches it. And there's a horizontal asymptote of y equals 0, and the graph never actually touches it. It gets closer and closer and closer, but never touches it. All right, let's go back to here. And by the domain and range, remember the domain are all the x's that are good. So basically all the ones less than 0 and all the ones greater than 0, but 0 cannot be not equal to 0. And for the range y is not equal to 0, so that means they're not continuous. One number in it is not included. Now, these are the steps for graphing it. So you find the asymptote, use that to determine the domain, and you don't actually need to do that in order to graph it, but it's there. You make a table of values with x in the middle, the undefined x. That's important there. And then you find 3 points one way and 3 points the other, close, close, far, and a close, close, far. Find the y values, and that gives you the points. You draw the asymptote, plot those points, and then you draw the curves with it and put arrows to finish it. Let's do this one as an example. I'm going to do, let's think, what should I do for this one? Well, let's do the, we could graph the basic 1 over x, actually, and let's see how it works. So x cannot be 0. You take the bottom of it, and actually what you usually do is you say x has to be, whatever is inside there has to be greater than 0. So right now, x is greater than 0, that's the domain, or less than, actually. The best way to say this is whatever this is, you make it equal to 0, solve for it if you can, and that's what you're not allowed to have, because that would make the bottom 0. But x equals 0 is thus the asymptote. Equals 0 is the asymptote. And so we're going to draw that by just doing approximate lines. It's hard to see on the graph when you go through that main one, but you see a little bit of reds there. Okay. And you put that number in the middle. So determine the asymptote, x equals 0. Okay. Use that to determine the domain. The domain basically are all numbers except 0, so x not equal to 0. Okay, so you could say all real numbers except. That's the term. All real numbers except 0. That's another way to show it. But simply saying x not equals 0 counts as the domain. So a table of values, we put the undefined x in the middle. And we don't actually have an answer to that. So we want two numbers that are close to it, like 1 and 2. And way out farther, like 10. And the other way, we'll go to -1, -2, and -10. So when we put those into the calculator, we get 1 over 1, so that's a 1. Right. And then if I put a 2 in there, that's 1 over 2, which is 0.5. And then 1/10 is 0.1. And then we get the negatives of those. Sometimes it's different numbers, so don't trust it to always be that. So we're going to graph these. 1 and 1 Well, and in fact, I want to erase these other ones we don't need so they don't confuse us. So 1 and 1 here, 2 and 0.5, and 10 and 0.1. You can see where this curve is going. And since it can't touch the asymptote, all it can do is get closer and closer and closer and closer to the asymptote, but never actually touches it. On the other side, and let's do the negatives, it's -1, -2.5, and -10, and the 0.1, and -0.1. That's the same kind of curve. You just have to make sure it doesn't actually touch the y equals 0. You've got to try to make it a decent line, which I'm not good at, but I think we'll do close enough here so that you can agree what it's supposed to be. Coming closer, but never actually touching those asymptote lines. And that's the way to graph it, is you determine the asymptote, you put that non-accepted number in the middle, and calculate 2 close and 1 far away on both sides. Now, let's move to some changes. If you have a horizontal movement one way or the other, if it's a +2, you're actually moving that way too. Everything moves that way. A -2, everything's moving that way. The vertical ones, well, here the plus actually works where it's up if it's plus, and it's going down if it's minus. And you can have both of them where you move it sideways and you move it up and down, and that's what the combined is. Well, let's look at this one, which is indeed a combined one. And remember, our first step is to take what's on the denominator, make it equal to 0, and let's move things around. -2, x equals -2. And that would be the asymptote. So that's a pretty important part. I'm going to graph that right now, actually. X equals -2. And I'm going to put that in the middle. Because remember, one of the rules, the third major thing, the second was find domain. Third is to do the, table of values. So it's come up. So we're going to make a table of values and we're going to put the X in the middle. And then we're going to take two numbers that are close and two that are far away. So I'll go the other way this time. If that's -2, and we have -3, -4, -10. And on the other side, well, we're going to from the -2 to -1 and to 0, and then out to +10. So the graph of this again is this. So y equals 1 over x plus 2, and then a +2 out here. So if I put 10 in there, I get 1 over 12 plus 2, which is out approximately 2.1. If I put -4 in there, I get 1 over -2. Okay, oops, actually, a little off. Oh, I forgot something here. That's a -10 that goes in there, so that makes that a -8. So it's to take away -1/8, which is actually about 1.9. Then the next one with -4, -1/2 plus 2 means it's about 2.5, which is about 2.5. And if I put a -3 in there, I get a -1 plus 2. So that means, is that -1. So, all right, so let's just plot these. Oh, we can't use this one at all. This is the asymptote. So at -3, it's a 1. At +1. At -4, oh, I went the wrong way with this 2. It should have been 1/2, 1.5. Okay, I'm sorry about that. -3 is 1. -4 is 1.5. And -10 is, oh, now see where, once I finally got those negatives, those numbers right, you see where this is going to graph. So the blue over here is the correct graph for the first part of it. Now let's do the next part. Okay. 2 take away 1 is 1 plus 2, so this is a 3. Put a 0 in here with 1/2 plus 2, so that's 2.5. Right? Put 10 in there, that's like 1/12 plus 2, that's like 2.1. So at 10, we're at 2.1, just a little above that. At 0, it's at about 2.5, and at -1, it's at 3. So we can see that these are supposed to go along here. And then this one's going to go up and just go along next to the asymptote. Now, if we put in like -1.9, we get a larger number way up there, probably 20 or something like that. But now you see how this is graphed. Okay? And I think I want the size of mine. Make this clearer for here. Oops, didn't mean to go over the red line. That's the danger with using a tool like this. Okay. Well, you can see I'm trying to make it more obvious for it. I could do the same thing on this one up here. But I think that's good enough. All right, so that's what it looks like. Notice what happens here is that when there's that x plus 2, the original would have been along here. So what happens is that the 1/x plus 2 plus 2, this one makes it move this way, and the plus 2 makes it move up. And that's exactly what happened. It moved over, and it moved up. Good. Now, take a look at, and in fact, back up here, that's, well, we saw that. Now let's take a look at what happens with reflection or stretch or compressed. For that, I'm going to come back over here to Desmos. The red line is the basic one. Well, when I use a negative, what I'm doing is I'm flipping it here. And that looks as if it's being reflected over the x-axis or the y-axis. So it turns out it tends to be the x-axis. So let me show you if we add a way to see what it is. That's going to be if I put a plus 2 here. Notice the red line moved up. Well, when I do that plus 2, well, I'm going to do minus 2, so it goes down. Now you can see that the first one, 1x plus 2, that the -1 in the second one makes it reflect over, right now, over the x-axis. Okay, not over the y-axis, but over the x-axis, okay, which is the y equals 0 line. Now, let's do away with those, because what I want to show you next is if it has a number up on top like that. Okay, now what that shows, that's the middle one here, where it's showing that the shape is being stretched out. And if it's less than 1, like this one is, it's being compressed. So let's go back and look at the graph. Okay, so the black line here, okay, it's stretching it. In this one, the green line is compressing it, where it's 0.2. Okay, it's like pushing it in and getting closer there to the origin, where the black one's coming farther out, it's stretching out, so it's like a little band does. Now let's go back and look at the graph then, that in this case is going to have a reflection. In fact, there's 3 things going on here. So this one will reflect, this one's going to make it go down 2, this one's going to make it move over to the left 2. Well, our first thing is simply to take the bottom, make it equal to 0, and when we subtract 4, x equals -4 is our asymptote, and for the domain, we would say that x is not equal to -4. But for the asymptote, okay, so let's go to where it's -4 and draw a line, a dashed line here. And the graph will not be, the curves of it, of the graph cannot touch that. And let's put that -4 in the middle. Now I'm going to take two numbers that are close, like -5 and -6. And farther away is the -10. And we'll look at -5, -6, and -10. Now the -10 is not that far away, but it still is enough to be able to graph with. And on the other side, we'll use the -4 and the -3 and the -2. Okay. And then lay out the +10 out here. Well, now let's calculate these. Get that back to a good size. And so y is equal to a -3 over x plus 4 minus 2. If I put -10 in there, I get -3 over -6, which is a +1/2 minus 2. And so 2 take away 1/2, -2 plus 1/2 is -1.5 or -1.5. Now, if I keep doing that with the others, there's approximately what I'm going to get. If I put in, oh, wait a minute, that's positive 10. I don't know why I went to the bottom, because I used a -10 here to get the -6. So it gives me a -1.5. If I put -6 in there, I'll get -0.5. And a -5 will actually give me a +1. Interesting numbers. Okay. So now if I put a -3 in and do the calculations, I'll get -5. -2 will give me -3.5, and 10 will give me -2.2. Let's graph these things. The -5 and 1 is the easiest first. -6 and -0.5 is here. The -10 is about 1.5 here. So what this graph does is go like so. Okay. Now it looks like it's getting closer to -2. That would be the y-asymptote. And so, oh, not y-asymptote. Yeah, this would be the horizontal asymptote. The other one's the vertical. So it's actually the number on the outside here that moved everything down. So now the other numbers, -3 and -5, -2 and about 3.5, and 10 and about -2.2. Going all the way out there to -10, it sort of confirms that y equals -2 is the horizontal asymptote. Now here the curve continues going and it has to go down. Okay. So this not one is actually like so. And this curve continues and gets closer and closer, but never actually touches the asymptote. And therefore now we've graphed this. So remember the steps for it were, one, to determine the asymptote. You can write the domain, but that doesn't help graphing it. And it's putting this in the middle and choosing numbers on both sides that are appropriate, and getting these numbers and plotting those points. So let's look at it and do a practice then. This is a good one right now where, watching this video, you might want to stop and do it yourself. So pause the video, go and do it. And when you come back, I'll still be here. In fact, I'll wait about 3 seconds on this program to before I start doing it, so you'll have time to turn it back on and come back. Well, welcome back. All right, so the first step that we do is we take that bottom and make it equal to 0, add 3, x equals 3 is the asymptote. Okay, so I'm going to go over to where +3 is. I'm going to do a dashed red line that shows what we're not allowed to have here. Okay. So we take that 3 and we put that in the middle here. And now we want to take two numbers on one side, like 2 and 1 and -10. And on the other side, like 4 and 5 and +10. And we're going to calculate this. Okay, so for each one, it's -2 over x minus 3 and then +4. So let's start with one of the maybe simpler ones. Let's start here with 2. So it's -2, -3, or 2 take away 3 is a negative 1 plus 4. So that's 2. 4 plus 2 is equal to 6. So we'll actually put a 6 in here. And when I do that with the other ones now, if I put in 1, I'm going to get a 5 here. And if I put in negative 10, I'm going to get like negative 13. It's 4 take away some little bit, or let's add some little bit with the negatives cancel in. And it gives us about a 4.2. Okay, now if I put a 4 in there, I'm going to get, actually I should do those in blue so it matches the other one. So with a 4, I'm going to get a 2, a 3, and a 3.7. So calculate each one of them like this, and you'll get those numbers. I'm going to go now here and put those in. 2 and 6. 4, 5, 6. All right, 1 and 5. And negative 10 and 4.2, which is just over, I'll put that on the intersection, which is just over this line, which looks like it's going to be the horizontal asymptote. Okay, so there's one of our lines. Now let's do the other one where it's 4 and 2, 5 and 3, and 10 and 3.7. So it's getting closer and closer to asymptotes here. Right? And this other one is y is equal to 4. So that's that line. And then, of course, the other line is x equals 3. Okay. So for the domain and the range, we would say not equal to those. All right, well, I hope that helps to understand how to do these, to find the asymptote, plot it, and put that number in the middle, and then plot points from either sides. Too close and one far away is safest to do. Hope this helps in knowing how to graph these and the different variations. Thank you for watching and listening.